The sky is not blue. That's something that fascinates me. Yes, it's true. The white light that comes from the sun contains all the colors of the rainbow. The blue gets scattered very efficiently by the air molecules. In this way, the entire atmosphere is filled with these blue rays of light, which are scattered everywhere, and that's why the sky is blue. In fact, a ray of light doesn't have color in itself. It's an oscillation of electric and magnetic fields with a certain frequency and a certain light. Wavelength. In the case of blue light, the wavelength is about 400 nanometers, but be careful, the ray of light with this wavelength takes on the blue color. Only when it reaches our eye, and especially when the information gets to the brain, only then does the brain assign it a blue color. In this case, philosophers say that now the light has gained an additional quality, that of color. If before it was just a simple electromagnetic wave, now our brain has assigned it an additional quality, color. These additional qualities are generally called qualia. Blue, therefore, is an additional construction of our brain, an extra quality, just like all colors. The sky is full of light waves, electromagnetic waves, especially with a wavelength of 400 nanometers, but the sky itself is not blue. Our brain makes it blue. Isn't that extraordinary? Here's something funny. In 1897, J.J. Thomson showed the electron is a particle. In 1927, over 30 years later, his son George P.J. Thomson showed the electron is a wave. Well, even so, both of them received the Nobel Prize because the electron is both a particle and a wave. It depends on the experiment we do. That's the wave-particle duality. Until today, no one managed to do a similar experiment with atoms to demonstrate, in a very similar way, that atoms can also be both waves and particles. Although this was known from more general diffraction experiments, the researchers from Cambridge took a very simple approach. A thin layer of graphene, which has a single monatomic layer, meaning the thickness of the layer is just the thickness of one atom through the monatomic layer of graphene. They passed hydrogen and helium atoms through it for up to 100 hours at speeds of hundreds of kilometers per second, so that the wavelength is comparable to the distance between the carbon atoms in the graphene. And surprise, they obtained a diffraction pattern similar to Thomson's, as you can see here, meaning that in this experiment, the hydrogen and helium atoms behave like waves. The wave-particle duality was once again confirmed for atoms. Why is this important? It enables a new kind of research. Similar experiments can also be done with molecules or their combinations. Where does this wave-particle duality behavior stop? Because we certainly don't experience this duality every day. We are a single, unified body. I'm sure that in the future the mystery will be solved. Subscribe to the channel if you want to find out as soon as it happens. We are living in the childhood of the universe. Every time you look at the sky, think about the birth of a new universe. Of our universe, you might say. But the universe is already 13.8 billion years old. It's not already old, is it? For it to be old, it would have to be close to the end of its life, and that could be very far away. In terms of what? Because space is still expanding after the Big Bang. Moreover, this expansion is accelerating so that the universe is approaching its end. It must first stop this acceleration of expansion, then decelerate until the expansion of space stops altogether. After that, the space of the observable universe should gather back together into a single point, just as it was at the Big Bang, and the universe would end its life through a big crunch. But hey, we don't know how long the accelerated expansion of the universe will last, because we don't know what dark energy is the one that causes it. In fact, we have no indication that dark energy will run out soon, even if dark energy is being consumed. Even if the expansion rate stays the same, we still don't know when expansion will stop or if space will ever contract again. For that, we would need to know exactly the total amount of energy in the universe and its form. Most stars in the universe are red dwarfs, which are smaller than the sun and burn in quotation marks. For trillions of years, all red dwarfs are in their childhood. As far as we know, the universe could even exist for eternity if the initial conditions allow it. During this time, even supermassive black holes would evaporate over trillions upon trillions of years, after which eternal silence could settle in. Most models estimate the universe will last trillions of years. There are also models that take into account the fact that dark energy could vary very quickly. These give the lowest estimate for how much longer the universe could last, tens of billions of years, most likely. So, we are in the childhood of the universe. Let's remember that when we look at the sky. This thing fascinates me. We don't know what elementary particles look like, and that's why we don't really know what anything in this world truly looks like. I know, maybe you drew the electron as a little ball in school, and I did the same in college. I found out it's always a wave. An electric field around it could very well be imagined as a field source. Then, in quantum field theory, I found out that all particles are actually packets of discrete energies of quantum fields. One would be a discrete energy packet of a field named Dirac. After so many years of study, I learned to accept my defeat. I actually don't know what particles themselves are, like electrons. All I ever have at hand are mathematical models of the electron, and I don't really do anything else but interpret one model or another. Simply put, we don't know what things are in themselves. All we ever have are mathematical models, which are always approximate, and these models are also essentially different from one another. The electron is either a particle, a wave, or a packet of energy. Who knows what will come next? Simply put, we don't really know what the universe truly is in itself. Why does the soccer ball curve when it spins in the air because of physics? Look here at how the ball moves through the air. You see how at the top, due to the rotation, the ball additionally pushes the air backward through friction at the bottom. That doesn't happen here. The rotation direction changes relative to the air, and friction between the ball and air pushes molecules forward. What is the total effect? The ball curves the air above it as it passes by, basically pulling the air downward, just like a gymnast pulls down on a bar. And today, what happens to the gymnast? Does he go up? The same with the ball by pulling the air downward? In this drawing, it is lifted upward, meaning the ball is deflected in its movement, in the same direction as its rotation. This is called the Magnus effect in physics. Next time, do you know how to score a goal better in soccer? Who can send telepathic messages instantly over huge distances? Forget about that. Can someone send messages into the past? How is that possible? Well, look, how can you think that instantly means you go to bed at the same moment as an alien who is a light year away? However, the theory of relativity destroyed this concept of absolute simultaneity. There are frames of reference in which you go to bed at the same time. Not with the moment when the alien goes to bed at night, as it is in your time, but with the one when the alien wakes up in the morning. On the morning of that day, meaning 12 hours earlier, let's say you now send him a telepathic message instantly. In this new frame of reference, when you are going to bed at night and, in your frame of reference, it is also night for him and he is going to bed. Because you are using this new frame of reference, the message will be received by the extraterrestrial in the morning of that day. Because here, in this frame of reference, these moments are simultaneous. Now, he is telepathically sending you the same message back. In the same way, in a frame of reference where, because it is morning for him, it is the evening of the previous day for you, in the end, the miracle happens. The message reached him 12 hours earlier and reached you 24 hours back in time, meaning the day before the one when you sent the message. That means the message traveled back in time because traveling back in time creates all sorts of paradoxes. It is believed that nothing can travel instantly in the universe, not even information, not even telepathy, if it even exists. Until next time, I am Christian Prasura, Physics Explained, and I wish you all the best. Goodbye.